Here I'm going to talk about my advanced data science capstone project, which is to predict the outcome of a League of Legends game in the first 10 minutes. Let's get started. For people who are not familiar with this game, I'm gonna give you a brief explanation. League of Legends is an online battle arena, for short, MOBA, video game developed and published by Riot Games. There are currently 12 international professional leagues. Each year, the best teams in each division will join together and fight for the world champion title. The World Championship game draws millions of views all over the world. It is currently the most popular esport event in the world. In a standard game, there are two teams of 5 players. The average game time is usually between 25 to 35 minutes. This game relies heavily on decision making. You need to quickly make decisions to collect more resource or prevent your enemies from getting their resource. In the map, there are different kinds of objects. Players will need to kill or destroy these objects to collect gold and gain experience. The ultimate goal for this game is to destroy the nexus of the opposing team. Now I'm going to talk about the dataset that I used for this project. This dataset is published on Kaggle by a community member. I put the link to this dataset down below. If you're interested, you can also take a look. Here's a quick overview of this dataset. In terms of the quality of this dataset, it has a usability score of 10 out of 10 from Kaggle. It is very organized, it has correct data format, and doesn't have any missing values, which saves us a lot of time since we don't need to clean the data. Here's the description for the variables used in this dataset. If you've never played this game before and doesn't know what each variable in this dataset means, you can spend some time and get familiar with these variables. First, we're going to look at the target that we're trying to predict, which is the outcome of games. It is the blue wings column that contains values of zeros and ones. 0 means blue team lost this game, 1 means blue team won this game. Here we're looking at how certain achievements in the game can affect the win rate. We can see that all achievements listed here give players a decent amount of boost in win rate by roughly 20%. The most important factor here is the number of towers destroyed. If you can manage destroy at least one tower in the first 10 minutes, it gives you an over 70% win rate. But in my personal experience, destroying a tower in the first 10 minutes is not easy. It usually happens when one lane has a huge advantage. Next, we're going to look at the total gold and gold difference. This is a bar plot that shows the distribution of these two variables. Here we plot the distribution of total gold and gold difference by if blue team wins or not. We can see that both follows a very healthy normal distribution. In the group where blue team wins, it has a higher mean. Next, we'll look at the distribution of total experience, experience difference, and average level. This is the box plot. This plot is very similar to the one that I showed you earlier. So total gold and total experience follow very similar patterns. As we mentioned earlier, if you can get the first plot in the first 10 minutes, it gives you a decent win rate of 60%. This is the count plot for several achievements. Dragons, heralds, elite monsters is just the addition of these two variables and towers as well. We can see it looks like dragon is the easiest one to achieve since it has the highest frequency. On the other hand, destroying a tower in the first 10 minutes is quite rare, like I mentioned. It only happens when one lane has a huge advantage. In most games, that's not the case. This is pretty much similar to the ones that I showed you earlier, except for this is a visualization graph. So it shows how each achievement will gives you a boost in win rate. Now we want to talk about minions. So minions are the main source of gold and experience in this game. Therefore, the number of minions killed also play a role in this game. Here's a box plot of this data. We can see the mean is around 220. For jungle minions, the mean is around 50. From this part, we can see when the total minions kill reaches around 225 to 230 in the first 10 minutes, the blue team will have a slight advantage in winning the game. Now we're looking at the correlation between each two variables. We can see total gold and kills are positively correlated. Total gold and total experience are positively correlated. Deaths and gold are negatively correlated. This plot can help us pick the right features to fit into the model later on. We kept most of the features in the original dataset and removed some redundant features. In the next step, we're going to start building the machine learning model. Here we split the dataset into train and test sets. We picked 3 algorithms for baseline performance evaluation, logistic regression, decision tree classifier, and extreme gradient boosting. For the performance indicator, we will choose accuracy and F1 score since this is a binary classification problem. Now, let's take a look at the baseline performance for these 3 algorithms. We'll pick the one with best performance. In this case, it's logistic regression for further model tuning. Before we move on to model tuning, I want to see if I can do some feature engineering and improve the baseline model performance. I create a series of new features by subtracting red team data from blue team data and take the difference. However, the model turned out to have slightly lower performance. Therefore, we're going to stick with the original data. Next, we use grid search CV and cross-validation to tune the parameters of the model. We're able to increase accuracy to around 74% with the following parameters. Now, we will build a simple neural network model using Keras. The model has one hidden layer of 22 nodes and an output layer of 2 nodes. I choose ReLU and softmax as activation functions. I trained the model 50 times. Now, let's take a look at the score. We can see that we're able to achieve around 72 to 73% accuracy, but after training the model 16 times, it starts to overfit the training model, so we'll keep our apples value at 16. Here we're able to see the best accuracy score is roughly 73%, which is very similar to the result that we achieved from logistic regression. Considering this is only the data from the first 10 minutes, it is acceptable. In the next step, we will try acquiring more data from Riot's database and use different features to improve the model performance. Thank you guys for watching. If you have any questions, feel free to comment down below. Peace.